Every time a water well is drilled in America, and there are more than 13 million of them, the driller writes down what came out of the hole. Clay, sand, gravel, shale, foot by foot, all the way down. It is the largest description of the underground ever made. So here is the strange part. Nobody had ever put it together. Surface water has a national home. One agency runs the stream gauges. One database serves them. Groundwater never got one. Those millions of drilling logs sit in 48 separate state filing systems, in 48 different formats, some as tables, some as scanned paper. And so our best national water models simplify the ground beneath us to a soil column about 2 meters deep. Every research team that needs the real subsurface redigitizes their own corner of it, by hand, over and over. The first step was simply to find out what exists. We probed the public data systems of all 48 states and learned you cannot judge a state by its website. Oklahoma looked like scanned paper. Behind the viewer sat a structured table with 250,000 wells. Kansas looked structured. The lithology column was completely empty until a bulk archive turned up with the real records. After systematic probing, the machine-readable share turned out to be more than twice what the surface suggested. 21 states, over 8 million wells, free for the taking. Then the harvest. State by state. Every record through the public pathway. No special access. Nothing you couldn't do yourself. Each source harmonized to one schema. State, well, depth interval, the driller's own words. Always kept verbatim, and a normalized material class. Quality control flags suspect values, but never fills, never invents. What emerged is a national picture. 28.5 million lithology intervals, describing the ground beneath 5.2 million wells, with coordinates for nearly 8 million across all 48 states. But 11 states keep their logs as scanned paper, 3 million wells locked in images. Those we read with a vision language model, and we tested it hard. California keeps 86,000 wells that were hand-transcribed by the agency. Against that benchmark, the machine matched depth boundaries with an F1 of 0.97 and material classes at 91.5% agreement. Cost, about 1,000 tokens per log. Reading California's 900,000 still-locked reports would cost roughly $260. The wall around that data was never money. It was that nobody had measured the door. And what does America's underground actually look like? Clay, 9 million intervals, the most common word drillers write. Sand, for 0.8 million. Gravel, 3. Shale, sandstone, limestone beneath. The typical described layer is 15 feet thick, and 90% of the record lies within the first 250 feet, exactly the zone where wells are drilled, contaminants travel, and models need structure. It is not a finished map of the underground. It is a framework, a method, and an honest, measured cost for finishing the rest. The data is open, on Zenodo, free to use. The paper is an open review at Earth System Science Data. And every record is the work of a driller who wrote down what the Earth was made of. We just gave their notes a single home.